Hey, it's Professor Dave. Let's do some graphical analysis.
He knows a lot about the science stuff. Professor Dave explains.
One of the best ways to do quantitative analysis is to make graphs. When we do this, we are plotting data points that correspond to two variables. And in physics, one of these will often be time. So we can label the x-axis with a t for time. And we could make tick marks for individual seconds, or multiples of 10 seconds, or whatever we want. On the y-axis, we will put some other variable, and right now we want to learn what happens when this variable is position, velocity, or acceleration. Let's go through an example and generate all three of these graphs. Say you are walking on a path in the woods on a fine autumn day. You walk the 1 kilometer path at a rate of 100 meters per minute all the way to the end of the path. Then you sit and rest on a bench for another 10 minutes, thinking about what to have for lunch. Once you've got an idea, you get very excited, so you begin to run back the way you came at a rate of 200 meters per minute. But after you get halfway back, you become tired and you slow down to 50 meters per minute. Let's represent all of this on a graph of displacement versus time. If the point where you started is the origin, and this point on the y-axis is 1,000 meters, where the bench is, we can draw lines to represent each section of your walk. First, you went the whole kilometer at a speed of 100 meters per minute, so over 10 minutes you went 1,000 meters. This line represents that activity because it goes from the origin, the beginning of the walk, to a point with coordinates of 10 minutes and 1,000 meters. Be sure to understand that this line does not represent a path in 2 dimensions. All the motion is along one line, but you are also moving forward in time, and that's what the x-axis represents. Now you are at the bench and you sit and look at the trees for 10 minutes while thinking about snacks. This means you will move forward in time by 10 minutes, but your position will not change. So this is represented by this horizontal line segment, ending at a point with coordinates of 20 minutes and 1,000 meters. Then, very excited about your pizza, you jog halfway back, or 500 meters, at a rate of 200 meters per minute. So this should take 2.5 minutes. This line segment will have a steeper slope because you are covering more distance in less time. And we can see that we are now at coordinates of 22.5 minutes and 500 meters. Suddenly, you get a cramp and you have to finish the journey at 50 meters per minute for the last 500 meters, which will take 10 minutes, leaving you at a point with coordinates of 32.5 minutes and 0 meters back to the place where you started, but later in time. One thing we will want to be able to do is to take this data and draw a graph for the same activity, but with velocity on the y-axis. To do this, we just translate each line segment. For the first bit, we see that we went 1,000 meters in 10 minutes, so that's a velocity of 100 meters per minute. So we can draw a horizontal line segment at 100 meters per minute, extending until the 10-minute mark, because you moved with constant velocity during that time. Then you were at rest for 10 minutes, so your velocity was 0. We can draw another horizontal line segment for that time period right on the axis. Then you began moving in the negative direction, so you had a negative velocity. That sounds strange, but remember that velocity is different from speed in that we are also reporting direction. So here, if we went 500 meters in the negative direction over 2.5 minutes, you had a velocity of negative 200 meters per minute, which is down here below the axis. Then, for the last 10 minutes, you had a velocity of negative 50 meters per minute, and there is our graph of velocity versus time. Let's point out a couple things right now. First, we notice that we only have velocity data when the object is moving. When at rest, the velocity is 0, because there is no displacement over that time period. Also, this is quite oversimplified, because it is impossible to go from a standstill to some velocity in an instant. In reality, there must be an acceleration or deceleration when starting or stopping. So that means if we were trying to be as accurate as possible, we would quickly ramp up to this velocity and then ramp down to rest, even if it's over just a second or two. This is important because we will now want to graph acceleration over time. And just the way that we can only have velocity data when the object is moving, we can only get acceleration data when velocity is changing. So there will be a positive acceleration as we just start moving, but it will then come to zero as we walk with constant velocity. Then acceleration will be negative as we slow to a stop. It will be negative again as we begin to walk back, and then back to zero, but then slightly positive when we slow down our movement in the negative direction. Back to zero, and positive again when we stop, as we require positive acceleration to stop moving in the negative direction. We will only have a non-zero value for acceleration when velocity is changing. In this way, every point on the acceleration graph is telling us about the slope on the velocity graph for the same point in time, and every point on the velocity graph is telling us about the slope on the position graph for the same point in time. If you are well versed in calculus, you know this means that velocity is the derivative of position with respect to time, and acceleration is the derivative of velocity with respect to time, which explains why we find instantaneous velocity on a position curve by looking at the tangent line. The slope of this line gives us the velocity at that instant, and the slope of the tangent line on a velocity curve will give us the instantaneous acceleration. We will cover all kinds of calculus in the upcoming mathematics course, but for now, we are going to stick to physics without complex math, since we are focusing on basic concepts. All we want to come away with now is the ability to draw and analyze these graphs for position, velocity, or acceleration. So let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.